All right, let's talk about a force you can't see, you can't taste, you can't touch. But without it, none of us would be here. We're diving into Earth's magnetic field, our planet's invisible shield.
You've all played with magnets, right? That weird push and pull? It feels pretty straightforward. But what if I told you the single biggest magnet in our lives, the one protecting our entire planet, works in a way that's, well, completely different? Its story is way more complex and honestly, way cooler than you might think.
Okay, so to get our heads around this giant planetary magnet, let's start small. I mean, really small. We're going to look at a simple bar magnet because the secret to Earth's shield actually starts at the atomic level. So get this. Inside something like a piece of iron, every single atom is its own tiny little magnet. But they don't just float around randomly. Nope. They team up. They form these little neighborhoods called magnetic domains, where all the atoms point their magnetic fields in the exact same direction, kind of like a perfectly disciplined little army.
But here's the thing. In a normal, unmagnetized piece of iron, these little armies are all pointing in totally random directions. It's just chaos. One domain's pointing up, another's pointing down, one's pointing left. You get the idea. And all that chaos means their tiny magnetic forces just cancel each other out. The net result? Nothing. No magnetic pull at all.
But this is where the magic happens. When you bring a strong magnet nearby, it's like a general shouting an order. All those chaotic little domains, they snap to attention. Suddenly, they all align, pointing in the same direction. And when they do that, their individual forces add up, creating one big, unified magnetic field, the one you can actually feel.
So the key takeaway here is pretty simple. Alignment creates magnetism. And that brings us right back to the biggest magnet in our solar system. Well, at least for us. Our home planet, Earth.
So, based on what we just saw, you'd probably think Earth is just a ginormous bar magnet, right? With all its little atomic domains perfectly lined up from the North Pole to the South Pole. I mean, it makes sense, but is that really what's going on?
The answer? Nope, not even close. The truth is, the way Earth generates its magnetic field is, well, it's way stranger, way more dynamic, and frankly, way more awesome than just a simple solid magnet. See, a bar magnet is a permanent magnet. It's solid, it's static, its power comes from those atoms all staying lined up. But Earth is an electromagnet. Its power doesn't come from a solid core, it comes from a churning, swirling ocean of molten metal deep inside the planet. It's not static, it's a living, breathing electric engine. And this incredible engine has a name, the geodynamo. Think about it. Deep, deep below our feet, there's a gigantic ocean of liquid iron and nickel, constantly swirling and flowing. This motion generates massive electrical currents. And, one of the fundamental rules of physics is that when you have a moving electric current, you get a magnetic field. That is the true source of Earth's magnetic shield. So, this geodynamo, it isn't just some cool science fact. It's the very thing that makes life on this planet possible. Let's talk about why it matters so much. That geodynamo creates what we call the magnetosphere. It's this huge, invisible bubble of energy around our planet. It's our shield. It's constantly deflecting a relentless stream of charged particles from the sun, the solar wind, and it blocks dangerous high-energy radiation from deep space. On top of that, it's the reason our compasses work, it helps guide migrating animals, and it's responsible for the absolutely stunning auroras. And make no mistake, the stakes are incredibly high. Without that shield, the solar wind would literally blast our atmosphere away over time. It would just strip it off, molecule by molecule, until our beautiful blue planet ended up looking a lot like Mars, a cold, barren, red rock. So this field is the silent guardian of everything we know. So how does this planetary engine keep running? Well, you need 3 key ingredients. Step 1, heat. You've got this blazing hot, solid inner core that acts like a stove, boiling the liquid metal in the outer core and getting it moving. Step 2, convection. That movement creates these massive, swirling currents of molten iron. And finally, step 3, rotation. The spin of the Earth itself takes all that chaotic swirling and organizes it, transforming it into the stable, powerful magnetic field that protects us all. And all of this, the heat, the motion, the spinning, it really drives home a crucial point. Our shield isn't static. It's not a solid, unchanging thing. Because it's born from a chaotic, liquid process, it's constantly in flux. It shifts, it wobbles, and sometimes it does something truly mind-bending. It can completely flip over. Yeah, you heard that right. It's called a geomagnetic reversal. It's a totally natural event where the magnetic north and south poles just swap places. Now, this isn't some disaster movie where everything happens overnight. It's a slow, gradual, kind of messy process that can take thousands of years to complete. So you're probably wondering, when was the last time this happened? The last full reversal was about 780,000 years ago. Let that sink in. To put that in perspective, our species, Homo sapiens, we didn't even exist yet. Now, if you look at the geological record, these reversals seem to happen on average every 200,000 or 300,000 years. So, given that it's been almost 800,000 years since the last one, well, you can see why some scientists say we're statistically overdue for the next one. Okay, so what would that actually mean for us living here today? Is this something to panic about? The short answer is no. The reality is much less end of the world and much more of a massive long-term technological challenge. See, as the poles are shifting, the magnetic field would get weaker and a lot more complicated. For our technology, that's a problem. Our satellites, our power grids, they'd be way more vulnerable to solar storms. For animals, creatures like birds and sea turtles that use the magnetic field to navigate would probably get pretty confused. And for the environment, yeah, a bit more radiation would make it down to the surface. But, and this is the most important part, there is absolutely no evidence in the fossil record linking these reversals to mass extinctions, not one. Life on Earth has been through this hundreds of times before. It adapts, it endures, it always finds a way to survive. So in the end, our planet's invisible shield isn't just some static thing. It's a living, changing, sometimes chaotic force. It's protected life on this planet for billions of years, and it's not stopping. But it is always changing. And that leaves us with a pretty big question. How will we, with all our technology, adapt to its next big move?